In this video, I want to go through an example of a decision tree problem. Let's go ahead and take a look at the following problem. We have the Hill of Beans Coffee Company operates a chain of coffee shops downtown and has decided to open a new store. The demand will be either fair, weak, or strong, and those probabilities are for weak, 0.25, for fair, 0.3, and for strong, 0.45. So those probabilities have been estimated. If the company installs a small booth that sells only coffee, the associated profits are negative 25,000, positive 25,000, and 100,000 for the weak, fair, and strong demand. If the company chooses an expanded facility that offers sandwiches and breakfast foods, it must build a kitchen and rent the additional space. The payoffs for an expanded facility are negative 200,000, negative 25,000, and 5,000 or $500,000. What should management do to achieve the highest expected payoff? So let's look at what this decision tree would look like. So we have our two options. We have our two ultimate decision-making conditions. Either we're going to build a small facility or expand the existing facility. And we know that there is going to be either a weak, fair, or strong customer behavior. And that's going to apply for both the small and the expanded. So we have the weak, fair, strong as well. Now, the only thing that changes, the probabilities do not change. The only thing that does change is the payoffs associated with the expanded, because we have the extra or the additional cost for the food and refrigeration and facility. Now, those payoffs are going to be different than the payoffs associated with a small facility. So let's go ahead and open up the starting file and determine which decision they should make based on expected value. Okay, so when we open up the problem, we do in fact see the decision tree. Now, decision tree theory basically works like this. Squares represent decisions. In this particular one, we only have one. We have terminal nodes, if you will, nodes that reflect that an expected value must be calculated. And we always work from right to left. So we're going to essentially collapse this portion of the tree down to a single value at any circular node. We're then going to collapse this tree down to a single value, which is the expected value, at this node. Simply, after you have collapsed all parts and you're left with the decision, you have to take the maximum, in this case payoff, to make your decision. So the maximum will be from the small node here or the expanded node here, and we're going to take the highest expected value to determine whether it's small or expanded. Now, this is a very simple tree. There could be many more decision nodes and event nodes. So let's take a look at this one in particular. Okay, so the first thing I'm going to do is work from top down. I'm going to label this particular event node as small event A node, I guess. And what I'm going to do is calculate this expected value. So let's provide a little formatting. And this should be suitable here. And I'm going to break it down into the three components just so we can accumulate these later. We have the expected value portion from the weak, fair, and strong. Okay, so that expected value, or that portion of the expected value, is simply equal to the negative 25,000 times the probability of 0.25. The fair would be 25,000 times the 0.30. Of course, we need those equal signs there. The strong would be the 100,000 times the 0.45. Now, all of these are components of the entire expected value. the entire expected value, and we can document that here. It's going to be equal to the sum of these three components. So if we are to evaluate this expected value, we have an expected value at this node right here of 46,250. We need to do exactly the same thing for the week, expanded. So let's copy this sort of template that we have and paste it here, and we're going to change these formulas, and now we have to update this. Now it's expanded, expand, and I'll call this event B node. These of course are arbitrarily. Usually I assign letters to the nodes A, B, and so forth. For the week, it's going to be negative equal to negative 200,000 times 0.25 in the probability. The fair will be negative 25,000 times the 0.30. And finally, the strong is the 500,000 times the 0.45. So, what we are going to choose in this particular situation, since we're dealing with payoff, is the maximum. And it's clear that the maximum between the two is going to be the expand event B node. So the max of the 46,000 and the 167,500 is going to be this. This corresponds with event B, which is to make a decision that we are going to expand. So let's go ahead and document this, and we'll just say decision is to expand. So that's it. So the trees can be much more complicated than this, but it follows the same behavior as this one branch. We collapse everything down to a circle with an expected value, do the same thing around the tree, collapse this down to a single expected value, and then we're left to make a decision here because we have a box, if you will. That box is decision 1, and we simply take the maximum of this expected value and this expected value, pick the highest, which is the expand. So that is our decision.